Today's learning target is I can determine slopes and y-intercepts of lines, and I can graph linear equations using the slope and y-intercept. Today we're going to be looking at equations that are set up in what's called slope-intercept form. Equations that are set up in this slope-intercept form will allow us to graph linear equations, or straight line, linear meaning straight line, equations. Slope-intercept form is set up this way right here, where y is going to equal, this m stands for the slope, so the slope of x plus b, and b stands for the y-intercept. Let's take a look first at what it means when we see y-intercept. So the y-intercept means where the line that we have here crosses on the y-axis. So we can see on this line right here, it crosses the y-axis at this point right here, which is 1. So that is why our y-intercept for this line is 1. And we know from the last lesson that slope is the rise over the run, or the change in the y-coordinates over the change in the x-coordinates. So if I have a line like I have here, I can figure out the slope by finding 2 points on that line. So for example, there's a point right here. I could place another point right here. I could place one right there. I could place one right here. So I'm just going to take and I'm going to place a point right there. Now remember, the top number in the slope is going to be the rise, or the change in the y. So the y is up and down, so I start from this point, and to get to this point I'd have to go up 1, 2, and up is positive, so my change in y is 2. And my change in x is going to be the bottom number, right, the run, the change in x. So from here I went up 2, okay, that was the change in y, and now I have to go positive 1 over to the right, 1. So that would be 2 over 1, which we know is the same as 2. So this equation right here represents this line right here. So that's how we would graph this equation. And if you think about it, that makes sense, because if we put a 1 in for our x-coordinate, okay, then I would solve this side of the equation. 2 times 1 is 2, plus 1 is 3. So y would equal 3 then. So that makes sense that our coordinates 1, 3 would be found on this line. So 1, 3, 1 goes here, 3 is right there, and that's where that point is. So if we have a problem like this, where we're asked to find the slope and the y-intercept of an equation, okay, we can remember the slope-intercept form. So just a reminder, that is going to be y is equal to m of x, remember m stands for slope, plus b, and b stands for the y-intercept. So when it's set up this way, it's pretty easy here. We've got our y, and we've got our equals. Now, this is going to be the m. Okay, it's right before the x. So the m stands for slope. So my slope is going to be 1 over 4. And now I have to find my y-intercept. Okay, but be careful, it's not 6, because notice in the equation, it has to be a plus whatever the y-intercept is. And I see this as a minus 6. So we are, instead of subtracting a positive 6, we're going to add a negative 6, right? So now I've got my plus sign right here, and that shows me that my y-intercept would be negative 6. So I would write that just like this. Let's take a look here and let's find the slope and the y-intercept of an equation that looks like this, where it's not in the slope-intercept form. So I know in slope-intercept form, just like this, I want to get the y by itself. Now I notice there's a negative 4x here, and I know I could cancel that out if I had a positive 4x on this side. Now, in order to keep it equal, I'd have to add a positive 4x to this side. So that'll cancel that side out. That leaves me with y equals 2 plus 4x. Okay, now I also know when I add, I can flip-flop the order of my adding and it doesn't change anything. And the reason I want to do that is now I can get the m of x, okay, the slope of x. So we can look at that and we'd say this would be the same as y equals 4x plus 2. And now it's set up in slope-intercept form. So 4 is my slope and positive 2 is my y-intercept. The other thing we can do with slope-intercept form is we can graph an equation. Now earlier in this chapter when we graphed equations, what we did is we plugged in a number for x, then we solved the equation for that, and that gave us our y-coordinate. And if we did that for 2 points, we were able to graph that line. However, the slope-intercept form makes it really easy to graph equations. So we know that slope-intercept form says y equals the slope of x plus the y-intercept. So looking at this equation, we can see that the y-intercept is going to be 3. Remember, the y-intercept is where the line crosses the y-axis. So it crosses the y-axis at 3, so I'm going to place a point right there at 3. Now, we know the coordinates here are 0, 3, and that makes sense because if y is going to be 3, okay, we would want this to be 0, x to be 0, because we want it to be on the y-axis. So x would need to be 0 in order for that to happen. So your x is 0. And now that I've placed my y-intercept here, now I can look at the slope. And the slope is right here, and I can see that's going to be negative 2 over 3. So remember, that's rise over the run. Okay, and the rise, just think of rising, goes up and down, and the run goes side to side. So the slope is a negative 2 over 3. So my negative can either go with the rise or it can go with the run. It doesn't matter. I just can't do it with both. Okay, so I'm going to take the rise as a negative 2. So that means I go down 2, and the run is a positive 3. 1, 2, 3. So I place my point here at 3, 1. Now once I have 2 points, all I need to do is draw a straight line that goes through those 2 points, and that will be my line that I can graph from this equation. So here's my line that I graphed, and you can see here's why it doesn't matter if I would have gone a negative 2 on the rise, or if I would have gone a positive 2 here and a negative 3 here. Because if I would have started at this point and I would have gone a positive 2 on the rise and a negative 3 on the run, take a look right there, that's where that line will go through. So this line shows us all the points for the x and the y that will make this equation true.